In this video, we are going to explore the relationship between the factors of a polynomial, the zeros or roots of a polynomial, and the graph of a polynomial. So first of all, we have this function, this polynomial function, and we're supposed to factor it completely, but we're given some information. We're given that x minus 3 is a factor. So right away, if x minus 3 is a factor, I can go ahead and list that among my factors. All right, x minus 3. If I were to set this factor equal to 0, that's going to give me one of the zeros or x-intercepts of the function. So if I set this equal to 0, I'm going to get x equals 3. That means that 3 is a 0 of the function, an x-intercept. Now, so our goal is to find the rest. Let's start off with synthetic division. Since x minus 3 is a factor, and setting that equal to 0, we find that x equals 3 is a 0. Then when we do our synthetic division, then we're going to start off with 3 in the box. The coefficients are 1, 3, negative 34. So 1, 3, negative 34, and 48. All right, in synthetic division, we bring the first number down. 1 times 3 is 3. Add, and you get 6. 6 times 3 is 18. Add these up. You get negative 16. 3 times negative 16 is negative 48. And we should always get 0 here because we know that 3 is a 0 of the function. So we should get 0 for the remainder. Okay, now that brings us down to the following. I'm going to turn this back into a polynomial. This is the constant, the x term, the x squared term. So this is x squared plus 6x minus 16. So look, so far I have factored the polynomial down, if you will. I started with this factor of x minus 3, all right, which is where I got this 0 of 3 from. These go together, factor and 0. And now I see the trinomial that's left behind after I factor out an x minus 3. But we have to keep going. So fine, I have this x minus 3 that I was given. But I can get 2 more factors if I could factor this down. So that's my goal. So I'm going to go ahead and try to factor this further. So x squared can only be x times x. 16. 16 is either going to be 2 times 8, or it could be 4 times 4, or it could, 4 times 4, or it could be 1 times 16. Now, looking at the middle term of 6, I'm liking 2 times 8, right? Because 8 minus 2 is 6, so that looks promising. So I'm going to try that first. Inner plus outer must equal middle. Inner, I have 2x. Outer, I have 8x. To get a middle of positive 6, I need a negative 2 and a positive 8. So there's my negative 2, there's my positive 8. Negative 2 times 8 is negative 16, so that's good. So now I have factored it the rest of the way. So I'm just going to copy this down here. So I had my x minus 3, but now I have also found my x minus 2 and my x plus 8. So now I have factored completely. That means the remaining zeros are positive 2, which I would get if I set this equal to 0, and negative 8, which I would get if I set this equal to 0. All right, so that is the complete answer to number 1. All right, now you may use your TI-30 to find one 0, and then we're going to factor and find the others. So when they say we can use our TI-30 XS multi-view, here's what we're talking about. If we hit the table button on our calculator, we have the opportunity to type this function in right here. So here I go. I'm going to type in 2x, and I'll use this to do the third power, get out of the exponent, and then minus 5x squared minus 14x plus 8. I've typed it in. I'm just going to hit enter. I always like to start with negative 10 because it rarely goes past that. And I'm just going to hit enter like 4 times until I get to this list. Now I'm looking for 0 on the y side because that means the x will be a 0 or x-intercept of the function. So I'm looking for 0 as I scroll down. It's getting smaller, well, closer to 0. And there it is. I find a 0 at negative 2. Okay, so I'm done with my calculator. I'm only allowed to use the calculator to find one 0. Okay, so I found a 0 at negative 2 right off the calculator. Okay, that tells me that there's a factor of x plus 2 when I factor this later. Now, zeros are what go in the box when I do my synthetic division. So I just found that 0 of negative 2. So I'm going to go ahead and put negative 2 in the box. And then my coefficients are 2, negative 5, negative 14, and 8. Okay, so I bring down the 2. 2 times negative 2 is negative 4. Add these up, I get negative 9. Negative 9 times negative 2 is positive 18. Add these up, I get 4. 4 times negative 2 is negative 8. And those cancel out. If you don't get 0 here, when you have just said that negative 2 is a 0, then you made a mistake. So this is sort of self-correcting. You should always get 0 here when you're doing this type of a process. So fine. The negative 2 gives me a factor of x plus 2. Now, these three numbers are the coefficients of a trinomial, 2x squared minus 9x plus 4. So far I have factored this polynomial down to a binomial times a trinomial. My goal is to keep going and factor this the rest of the way. So I'm going to just bring down my x plus 2, but I'm going to continue factoring the trinomial. 2x squared is 2x times x. It's the only way to do that. Now 4 is either going to be 2 times 2 or 1 times 4. Now normally I would start with 2 times 2, but that causes a common factor to appear inside the parentheses. And if there's no common factor in the polynomial, there should be no common factor inside of the parentheses either. So I know that 2 times 2 is not going to work for that reason. So it must be 1 times 4. Now here again, I know not to put the 4 here and the 1 here, because that would again cause a common factor. Both of these are divisible by 2. So I won't waste my time on that guess. The only possibility is putting the 1 here and the 4 here. Inner plus outer equals middle. Inner, I have 1x. Outer, I have 8x. I'm trying to get negative 9, so I really need both of these to be negative to make negative 9. And a negative 1 times a negative 4 is a positive 4, so I have now factored it correctly. Okay, so now I have all of my factors. So I'm just going to copy this down. So I have my 2x minus 1 and my x minus 4. Now the zeros are what I would get if I set each of these equal to 0 and solved. I've already got the negative 2 that I got off my calculator anyway. But if I set 2x minus 1 equal to 0, I'd have to add 1 to both sides. That would be 2x equals 1. And then I would divide both sides by 2, and I'd get x equals 1/2. So 1/2 is 0. If I set x minus 4 equal to 0, I'm going to get x equals 4, adding 4 to both sides. So those are my factors. I have factored completely, and these are my zeros, also known as roots, also known as x-intercepts. So that was problem number 2. Problem number 3. I'm supposed to write a standard form equation for a polynomial with the following zeros. Now, I'm noticing that I have a real 0, but I also have an imaginary 0. One thing we have learned is that imaginary zeros always occur in pairs, conjugate pairs. So if 2i is a 0, that automatically means that negative 2i is also a 0. They go together. So it looked like I gave you 2 zeros, but I actually gave you 3 zeros. Okay? Now, starting with my imaginary zeros, I'm going to convert these back into factors. So this a 0 of 2i would come from a factor of x minus 2i. A 0 of negative 2i would come from a factor of x plus 2i. Right? In other words, if I were to set this equal to 0 and solve, like x plus 2i equals 0, what would I get? Well, I would subtract, and I would get x equals negative 2i. So that's what I mean when I say this factor goes with this 0. Anyway, similarly, the negative 1. What factor would give me a 0 of negative 1? Well, a factor of x plus 1. If I set that equal to 0, I would get negative 1. So these are my factors right here. Okay? So I need to multiply these together, but you should definitely multiply the imaginary parts together first. So for right now, I'm going to keep the x plus 1. And I'm just going to multiply these. All right, so you know I'm doing the double distributive property. So I'm doing x times x and x times 2i. So that's going to give me x squared plus 2ix. And then now I'm going to do negative 2i times x and negative 2i times positive 2i. Might need a little more space. Negative 2i times x is negative 2ix. Negative 2i times positive 2i is negative 4i squared. All right, negative 2 times 2 is negative 4. I times I is I squared. So what's going to happen now, guys? I'm going to just recopy my x plus 1. This cancels out. So I just have x squared. I squared is negative 1. So this is like having negative 4 times negative 1. So that's why this is going to become a positive 4. So in the end, when I did x minus 2i times x plus 2i, the middle part canceled out, all the i's canceled out, and I just have x squared plus 4. So now I need to do the distributive property again. Okay, so when I do x times x squared and x times 4, I'm going to get x to the third power and then plus 4x. And now I'm going to do 1 times x squared and 1 times 4. So that's going to give me plus x squared plus 4. Now I need to write this in standard form, so I'm just going to switch these around. So in the end, I will have x to the third power plus x squared plus 4x plus 4. That would be my final answer for number 3. All right, number 4. Draw a sketch of the function using our knowledge of zeros, multiplicity, and end behavior. Well, so there's a bunch of things here. I see 2 different factors. I see x plus 4, which is repeated twice because it's squared, but I see x minus 3. If I were to set these factors equal to 0, all right, if I set x plus 4 equal to 0, I'm going to get a 0 of x equals negative 4. All right, that is going to be the one of my x-intercepts. So let me just put negative 4 here as a reminder. So I'm going to have a 0 or x-intercept at negative 4. Similarly, if I set x minus 3 equal to 0 and solved, I would get x equals 3. All right, x minus 3 is the factor. X equals positive 3 is the 0, also known as the x-intercept. So I'm going to have an x-intercept here at positive 3. So that's one thing I need to know. Now, here's something else. Depending on the multiplicity of the factor, meaning how many times it's repeated, it will affect what happens at the intercept. Let me show you a little diagram. If the multiplicity of the factor is 1, if there's just one of them, then the graph passes straight through that x-intercept. If the multiplicity is 2, then the graph bounces off that x-intercept like this. And if the multiplicity is 3, it forms something called an inflection, where the graph sort of flattens out as it passes through that x-intercept. So straight through, bounce, or inflection. And I often will abbreviate with an S, a B, or an I. It's supposed to be an I. Anyway, let's get back to the thing. So x plus 4, multiplicity 2, there should be a bounce at this x-intercept. This is multiplicity 1, so this one should pass straight through. Okay, so at negative 4, there should be a bounce, and at 3, it should pass straight through. Now, before I finish drawing the graph, I need to think about my knowledge of end behavior. There are only 2 kinds of end behavior for polynomials. Some polynomials have end behavior like this, and some polynomials have end behavior like this. In other words, either both ends point in the same direction, or we have one down and one up. So it turns out that you're going to have, let's see, how do I organize this? You're going to have this type of end behavior, both pointing the same way, anytime you have even degree, like 2, 4, 6, 8. If I have odd degree, then that's when I have one down and one up. And of course, this is the positive version of the graph. If the leading coefficient is negative, if there's a negative in front, then that's going to be a reflection over the x-axis. So that would look like this for an even degree, and that would look like this for an odd degree. Now, bear in mind, I'm not talking about the entire graph looking like these shapes. I am focusing on the end behavior. I'm just talking about what's happening on the ends. Okay, just the end behavior is all I'm looking at right now. So, question is, what's the degree of this polynomial that's written here in factored form? Well, there's two of these and one of these. So that means that the degree is 3. All right, two of these, one of these, that's degree 3. So degree 3. So when I talk about degree 3, I'm talking about odd. So it should have end behavior like this. Now notice this is positive. There's no negative in front. So it should specifically have end behavior like this graph right here. All right. So it should start low and end high. I think of a capital letter N to help me remember the way that odd functions look as far as end behavior. It's like capital letter N. So this tells me I need to start off low on the left hand side. So I'm going to start from down here because of my knowledge of end behavior. But when I get to the -4, I need to do a bounce. So I'm going to start off low and I'm going to do a bounce at the -4. Now I need to work my way back to my other x-intercept. I need to be careful not to cross the x-axis anywhere else. There are no other x-intercepts. But when I get to the 3, I'm going to pass straight through. So when I curve back around, I'm going to pass straight through. And there you go. Notice how it looks a lot like the sketch that I predicted. All right, number 5. Give a possible function in factored form for the graph shown below. So we're just going the other way. So let's look at the zeros or x-intercepts of the function. So we have these zeros. We have a 0 at -2. And we have a 0 at 1. Now, at -2, notice the graph goes straight through. And at 1, notice that there's a bounce there. Now, let's talk factors. So, because of the 0 of -2, that would come from a factor of x plus 2. Imagine if you set this equal to 0 and solve, you would get -2. That's how you know this is the right factor. We would need a factor of x minus 1 to get a 0 of positive 1. So we have these factors for sure. Now we just have to worry about the multiplicity. Well, this one went straight through, so this should have multiplicity 1, so I'm not going to give it an exponent. This one was a bounce. A bounce happens when you have multiplicity 2, so I'm going to give that an exponent. The only thing that's left is, do I need a negative sign in front? Okay, is this should this be a positive leading coefficient or negative leading coefficient? Well, I see that this is making sort of an N shape here, right? If I focus on, you know, just look at this part of the graph right here, for example. Can you see that that's making an N shape? So the only question is this a right side up N or is this an upside down N? Well, this is very much like a normal capital letter N. So that helps us remember that this is right side up. This is positive. So I do not need a negative sign in front. Okay? So I think I'll just erase the word factors. And I'll just write f of x in front. And that'll be it. That's going to do it for this video. I hope it was helpful. I'll see you on the next video.